Only the minutest of changes in a seemingly endless chain of genetic information can make all the difference between an individual's good and poor health. Certain mutations can dramatically increase the risk of a heart attack in a human being. Every year, 750,000 people in Europe die from the consequences of a myocardial infarction. The hunt for the genetic causes of heart attacks can be compared to the search for the proverbial needle in a haystack. As an analogy, the human genome can be compared to a book of 1,000 pages, where all we are looking for is a small typo in a single word. As you can imagine, this represents an immense undertaking that has consumed much of our effort and endeavor for the last 15 years now. The Institute for Integrative and Experimental Genomics at the University of Lübeck was born out of a study initiated in 1997, which culminated in the establishment of a fully fledged working group in 2004. In close proximity and constant collaboration with the University Hospital of Schleswig-Holstein at its Lübeck campus, an international team of 25 scientists has dedicated itself towards studying the genetic causes underlying myocardial infarction. The scientists are globally connected. As a result of years of cooperation in Lübeck, they have built up a very close collaboration with the research group led by Professor Heribert Schunkert, director of the German Heart Center in Munich. For many years now, scientists have been analyzing the millions of markers within the genomes of many individuals, including about 100,000 volunteers who are affected by a myocardial infarction. The hereditary causes of this life-threatening disease has now been scrutinized using a number of highly complex statistical and bioinformatic methods. In the fall of 2013, there was a major breakthrough. Under the direction of Professor Janet Erdmann, the research team was able to identify a single family from northern Germany with an unusually large number of heart attack patients and to identify and indeed prove a genetic connection. There was in fact a double mutation, meaning that those family members who had two mutations in two specific genes that interacted with one another had a very high risk of suffering a heart attack at an early age. This represented a true milestone in genomic research. The use of next-generation sequencing methods has allowed researchers to decipher the pathogenic DNA sequence from only a single droplet of blood. Subsequent analysis in the laboratory has proven that these altered DNA segments are responsible for the formation of blood clots.
We have identified several genes that we are investigating in the laboratory to understand how these genes influence the risk of a heart attack. Only when these mechanisms are understood can new therapies be developed.
Our intention is to determine the genetic causes of heart attack piece by piece, meaning that every day we are learning something to accomplish this. Although this is a lot of fun, it is also a lot of hard work. Theorists and practitioners interact on a daily basis at the Institute. Computer scientists analyze the data and create evaluation pipelines, while biologists in the laboratory confirm the predicted models. Together, they are deciphering the genetic mechanisms underlying myocardial infarction on a step-by-step basis. The major day-to-day challenge in our institute is to lead and guide our theorists and practitioners in an integrated manner. This is not always easy, because two sides of a coin can have different ways of approaching a problem. I do think that this cooperation has been a hallmark of our outstanding success in recent years. Myocardial infarction is the most common cause of death in the Western world. The application of our scientific knowledge towards develop new therapies for patients provides the real day-to-day incentive for the scientists in the Institute for Integrative and Experimental Genomics at the University of Lübeck.